I've just got OC minus OA, and we're subtracting this, you're getting -5, also we are getting 5. So we have to see what's similar or what is common. Another thing that we are saying that you can express in terms of the other, or still you can get ratios. Still, that is very okay. Like for example, when I look at this one, I can factorize out the 4. Same thing I can do it for SC. I can put outside the 4. So when I look at what I have, I can say this is AB. AB can be equal to 4, and I have -1, 1. I can have that. So that is my AB. Also for SC, I can say that my SC can still be equal to 5. This is -1, 1. Remember, when you multiply, you go back and get the same thing. So now I want to see how I can express them in terms of the other. I can express one in terms of the other, or I can get ratios. Still, that is very fine. Now, depending on whatever I want to do, I can express or I can get ratios. So one easiest way of doing that is that I can divide, I can divide, or still I can make one of them, like I can make this one which is common in the constant. There are many ways. I can't exhaust all the possible ways here, but I want you to understand that you can do it in very many ways. You can substitute, that's one way of doing it, or still if not that, you can divide. Like for example, I'm going to divide. I can say this is AB, so I can get AB divided by SC, so I can divide these two. So I want to establish a relationship between the two of them. So when I divide, it means that up here AB is 4, -1, 1. Can have it like that. Then down here for SC I have 5. This is -1, 1. So I end up having my AB out of SC. This will be equal to, so this one will cancel out, so I'll be having 4 over 5. Now I can write this one in terms of a ratio. I can say that AB, I can say AB to SC. See that? I can say AB to SC will be equal to 4 to 5. So still having this relationship between it means that they are parallel vectors. Another way of doing it, I can also express one in terms of the other. Like there are very many ways in which we can represent this information. When I have this and I have this, somebody can also multiply by SC. You see? Multiply by S on both sides, that means I will be having AB. So there are many ways, and we need to understand all the possible ways, because you're going to look at numbers in the vector diagrams where they can give you all these concepts in different ways. So you see, even if I say AB equals 4 out of 5 SC, so it means the constant is here and they are parallel vectors. Other person can do like this, can multiply by 5 here, and also we have 5AB. Now we need to understand all these things. They mean the same thing. Just need to know how to express them. So another person might have this, I have this, I have this, I have this, but all of them they are giving us the same information. So here I can leave it in terms of ratios. So we have AB equals to SC, AB to SC equals to 4 to 5. Then, since we have a common point of reference, remember what I told last time, that we must have a common point, which is A, and again we have their parallel vectors, depending even we have a ratio. Therefore, they are A, B, and C are collinear. So since we have this, so since AB to SC equals to that, therefore, AB and C are collinear, or they lie on a straight line. So you need to understand that. So it means that we have this line here, but again it's being divided because that's why we have these ratios. Understand that the same information is what is represented by this, is what is given by this. So we really need to understand that. That's why there are some people who do these things by cramming, and they just know we have to do this, we have to do this. But all this is the same information. It is the same information. It's like when you are going to divide something, maybe me and maybe I have my friend, I have many friends there. And if you are going to divide maybe anything, maybe money, and I say maybe you are going to divide in a ratio of 2 to 3. Yeah? So there is a relationship. I'm giving it in terms of ratios. But the other person might also say that if I'm going to get 2 and we're dividing 2 to 3, I can still say I'm going to get 2 out of 5. You see, it is the same information. or I can say that the other friend of mine is going to get 3 out of 5. So it is the same information, but given in different ways. So we are representing the same information, but in different ways. So that's what we also will look at here when we talk about these ones being parallel vectors. So one thing that they are parallel vectors because we have this, and again, we have also used the same point, which is A. So the points here, they are supposed to be, or they are said to be collinear. They are collinear, they are going to lie on a straight line. That's how we can do that. But again, I always want to use, like this example, I want to use it to talk about other things. You know, there are things that that I've not got a chance to talk about. But I'm going to use the same number. I talked about where we have points lying on a straight line, but still have the same gradient. And I want also to work on that. You can prove it on this number that, you know, these are 3 points, A, B, and C. We have proved that they are collinear or they're lying on a straight line. So see, it means that any 2 points that I have to choose, if I choose A and B, or B and C, or A and C, any 2 points, I must get the same gradient. Yeah, I have to get the same gradient. Why am I bringing this? Last time I talked about it, is that there are some numbers you're going to find. I've placed some numbers here, you're going to see them. There's some numbers you're going to find and you won't be able to do them unless when you know that you know, when I get some 2 numbers and I have some 2 coordinates and they're lying on a straight line, they must have the same gradient. Because they can give you like 3 points and there's one of them which is unknown in the coordinates. So you have to find that unknown. So you need to use that concept that they must have any points got, any 2 points got from a line, which is a straight line, they must have the same gradient. So we're going to try it on this number, and I know when you come across those numbers, life will be good. So that's how we show they are collinear. But I want to work out this. We have A, B, and C. So we are going to use them, and we see that we can have the same gradient. So it means that gradient of AB is the same as gradient of BC. It's the same as gradient of maybe still, if I say AC, they have to be the same gradients. And I want us to try it out. Then we can do even the part B. We can do the part B still. So for example, we are having our A is 3, -1. And we also have our B, which is -1, 3. And also we have our C, which is -2, 4. So I want to just look at, just get maybe gradient AB. So I want to get gradient of AB, line AB. So this will be, you know, we have to get gradient. Changing y after changing x. I talked about that last time. So I'll get y2 minus y1 out of x2. So you have to use this out of x2 minus x1. So if I use this 3, then minus -1. And also I can have -1 minus 3 for the values of x. So this will give me up, I'll be having a 4, then divide by -4, which will give me a -1. So you are seeing that gradient of AB. So I want you to see this concept that is very true. So when you come across such numbers, you have to use the same thing. So gradient AB is -1. Now also I can try gradient of SC to see if still I get -1, because if these points are collinear, then they must have, any 2 points on the line must have the same gradient. So we have AB, that's true, -1. You're also going to try to get gradient of SC, then we see that still we have the same gradient. Then we can go to our part B. We are going to use this concept in some numbers ahead. So we have to find also gradient. I want us to find gradient of SC, gradient of SC. So SC, so I'm going to use the same formula, find a gradient, changing y after changing x. And for SC, I'm using C and A, so I'll be having 4 minus -1, and out of -2, this is minus 3. That's what you're having. So you have -2, because I'm just getting for SC. Now see, when you have this one up, I'll be getting a 5, then divide by -5. So see, the gradient here of SC will be equal to -1. So we're going to use this concept. I just wanted you to see it, because last time I talked about it, but we didn't do some numbers for you to see that it is true. For a line, any 2 points you pick and you try to get a gradient, you must get the same answer for the gradient. Like I've used A, C. I have used AB. Even if I use BC, it must be the same gradient, -1. Now let us look at our part B. Yeah, actually we have it here. So this was just as a by the way to show that to you, and you're going to use it in some of the numbers. So I want you to know that any 2 points, if at all you have a line and you pick any 2 points to find a gradient, then it has to be the same for any 2 points that you pick, if at all they are lying on a straight line. So we are going to look at the part B of our question number 3. They're telling us to find the coordinates of D if CD equals to 2, BD. That's what you're going to work out. We want to get the coordinates of D. So they gave us a condition here that CD equals to 2, BD. That's what we have. And I want us to get the coordinates of D. Now, I want you to understand this, that even if they are giving us CD, BD, now we're talking about coordinates of D, they want the position vector of D. And so that this one, position vector, we get from reference, the origin. So it means that getting CD, we can express CD, BD in terms of their positional vectors. So it means that CD is something as having OD, then minus OC. And again, when you come to 2BD, the same thing as saying still that this will be 2, then 2 brackets, I have OD minus OB. So I need to get the coordinates of D, which is the same thing as OD. Now, there are many ways of doing this. If you want, you can let those coordinates of D to be maybe X, Y. But again, I can first organize it. Actually, even I think it will be more easier for me. I can first expand this, then I put OD on one side. I express OD in terms of OB and OC. I think that will be a little bit easier. So I don't need to write anything. You're going to see how we do that. So this is OD. Let me open brackets here. So it means I'll be having OD minus OC. Then this will be equal to 2. This one has to multiply everything. So I'll get 2OD, then minus 2OB. Yeah, we have that. So what we have to do here, I want to collect like a terms. I want to put OD on one side. So it means that this OD can come this side, or depending on whatever I want to do. I can bring OD this side, or I can take this OD the other side. And I want to do what's easier. I don't want to confuse you, because anything that you do, it will come out. But you see, I know most students, they fail on this. When they try to bring 2OD this side, then they will get a negative OD. And some students, that will trouble them. You know, they divide by negative, it will give them some more time. So if I want to avoid that, I can still take this OD this side. So when it comes a negative, I subtract 2OD minus OD, I get OD, which is positive. Then it means I have to bring 2OB this side. That's what I have to do. So I'm going to do that, then we can get our OD, or coordinate D. Yeah, so it means that if I take 2OD this side, so I'm going to have 2OB, then minus OC. This will be equal to 2OD minus OD. So I've just tried to arrange this one. So now after doing this, I'll be having my 2OB minus OC. This will be equal to OD. If I subtract 2OD minus OD, I'll get OD. So it means that my OD now can be good. I just have to put OB and OC. But see, OB is the same as B, the coordinate, even C is the same thing. I just have to substitute. So I'll be having my 2 into OB, which is -1, 3, then minus OC, which is -2, 4. -2, 4. So I just get my OD. So this will have to first multiply here. This will give me -2. But this has to multiply everything. -2, then this is 6. And then minus -2, 4. So we need to work out this. This is what we started with looking at the column vectors. the operations. So I'll get -2 minus negative. So this one I get a positive because it is -2 minus -2. So it will come -2 plus 2, which will give me a 0. And again, I get 6 minus 4, which will be a 2. So OD becomes O2. But I said they want the coordinate. Now when you stop here, this is not a coordinate. You are putting it in a column form, so they will be denied 1 mark. So the coordinate of D, it has to be like this. So the D coordinate is going to be 0, then 2. So I want you to, with the same coordinate, give your answer in this form. Yeah, so that is the answer there. So we just need to know how to plan with the position vectors, and last time I talked about that. Understand how to express these BD in terms of their position vectors, which we get from reference from the origin. So we say that there are many ways. Even if I say it's going to be OB plus OD, or this is BO plus OD, still it's okay. Know that BO is same as negative OB. You will go back and get this. But still, we talked about this, that you look at what is the last letter. This is D, so you're going to get OD minus OB. So this will be the coordinate for D. It will be 0, 2. Then you're going to look at number 4. I think I can go to number 4 now. We have a lot of questions, and I want us to look at most of them, because every question there is addressing a particular concept that is very good for us as mathematicians. So let us look at number 4. Number 4, they are giving us still some coordinates there, and they are going to be also good for us. So let us solve number 4. The questions are 10, and I want us to go to number 4. Number 4. So I want you to really understand all the things that they can say about this topic. So for they are telling us that points A, B, C, we have -3, -2, 3, 1, and also we have point C, which is K, 2, lying on a straight line. They're saying find a value of K. Let us work out this one here. Let us work out this then, because I see we have a lot of questions to do, which are all good. So what we have to do here is that we're going to use the concept that if you get any 2 points lying on a straight line, like I have A, I have B, I have C, and the 2 points lying on a straight line, they have to give me the same gradient. Like in the previous number, I've proved this for you, that when I got the gradient of AB, gradient of AC, I was getting the same answers. So we are going to use the concept here. So we want to get the value of K, so I can get gradient of AB, you see, gradient of AB, and also I have to involve this other point. I also get gradient of C. So I equate them, because these points are lying on a straight line. They must have the same gradient. Any 2 points I get must give me the same gradient. Even if somebody decides to get AB and BC gradients, and you equate them, see, you get the same answers. Whatever 2 points you get, and you get the gradient, the answers will be the same. So look at what I'm going to do here. I can just say that we have these points. And again, we have very many ways of doing this number. But look at this. I want to use the easiest way, and this is when we use the gradients. So if I take gradient of AB, since these points are collinear, gradient of AB, I'll be getting, change in Y. So this can be my X1, Y1, X2, Y2. So please, the sample fail this number because of interchange in how they're getting the gradients. There are some who use change in X up, change in Y down. There are many things that you do. Some people they get Y1 minus Y2. you can use that, but again, you have to maintain even for the other one. But some of us, we do it up, down, you do something else. So just get change in y out of change in x, which can be still y2 minus y1 out of x2 minus x1. So there are many ways we can play around with these things, but provided we are solving, we can get the same answers. But I want you to use this formula to get the gradient. But if you are using y1 minus y2, also you have to maintain down for x1 minus x2. But again, don't put x up. So you can always use this. So my gradient of AB, so when I don't have the arrow here, it means that I'm looking at line AB. So I'm just going to get gradient of AB, and this will give me 1, because my 2 is 1, then minus negative 2. Then divide by x2, which is 3, minus negative 3. So this will give me, this becomes plus 1 minus, so I'll get 1 plus 2, which will be 3. And again, here I'll be having 3 minus 3. This will give me a 6. So it means that my gradient of AB here will be equal to a half. When I reduce this, it will be a half. So just go to y2, which is 1, because I'm using AB, 1 minus negative 2. That's why I'm getting a 3, then 3 minus negative 3. So I get a 6. My gradient is a half. So it means that even if I get gradient of AC, or I can take BC, whatever I get, they must be the same, the same values for the gradients. So I have gradient AB is that, but for them, since they are collinear, for A, I can just write this for A, B, and C. To be collinear, then it means that gradient AB, this will be equal to gradient of S here. I just want to also engage in this because I want to find some unknown there. Or even if you use BC, C, it will be the same thing. So now I'm going to get gradient of SC, then I equate it to gradient of AB, which I've got as I have. Then this will help me to get the value of K. But again, I'm saying that there's a different way of doing this number. But in this case, this is the easiest way that you can use. But you're going to see in other numbers, because I try to address every issue. So you're going to see in other numbers that still there's a point where this one will not work, that you go for the other method, which I'm going to show you in the other number. But here, this could be easy. This is the easiest that you can use when you're given coordinates, 3 of them, and you're having an unknown. You can use the gradients. But you'll be seeing that there are cases where this will not work, and that's where the other second method is going to come in. So we're having this. So we are going to get the gradient of SC, since already we have for AB. So my gradient of AB, we already have it as a half. So it means that this half I've obtained for gradient AB, gradient of SC. So SC, I'm getting the same formula, change in Y, then out of change in X. So I'm getting my 2 as my Y2, then minus Y1, which I'm taking from A. So this will be negative 2, then divide by my K, which is the X2 now, minus the X1, which is negative 3. So I'll be having that. And now this will be equal to a half, because already I have gradient of AB. So when I work out this, this will become a 4. Down here, I'll be having K plus 3. This will be equal to a half. Now what you have to do next here is we are looking for K. I think here it's now the vectors, collinearity, all that is done. So here it's about solving. You have to solve this equation and find the value of K. So I can do it by, I can cross multiply. So when I cross multiply here, it means that the 2 multiply the 4. So I'll be having K plus 3. Of course, times 1, you get K plus 3. Then this side, I'll be having the 2 times 4 here. So I'll get the K plus 3. This will give me an 8. So it means that my K will be equal to 8 minus 3. So value of K here will be equal to 5. Yeah, my value of K will be 5. So that becomes the answer for that number. we are asking us to find the value of k, that will be the answer. So please, when you find such numbers, yeah, go for them. You know, go for them. Don't want excuses that no, this one we never covered at school. Our teacher did not cover this. Here at BBS, we are doing everything. You know, nothing is left out. So don't give such excuses. You just have to do these numbers and you pass them. You know, some people are saying that those numbers they didn't cover, but this is how we do them, and they are very easy numbers. That's why we are not supposed to leave any stone unturned. That whatever they bring, you know, that's how we prepare our students. Whatever they bring, you can do. Any question, whether it's from where, you can do those numbers. So let's look at number 5. Look at that number 5 there on the questions we have. Number 5 almost, it is the same as what we have done. They're giving us points x, y, z. They're saying they're collinear, find the value of c. So that number, I'm leaving it out. You would do that number 5. It is similar to what I've done. You know, don't have a lot of time. If a number is almost similar, you can do it. So number 5, please, you do it because it resembles what you have done exactly. Now look at number 6. They are saying that if vectors A, I think you can do that, vectors A and B are parallel, then find the value of n. Yeah, I think this will be very good. So we can do 6, but 5, please, you do it, try it out in your free time. Yeah, then most of you, I see, you normally send, you can send. But I believe everybody who is attending this lesson now cannot fail that number 5 because it is the same concept we've just done. So we're having number 6. So you have vectors A, which they're giving to me as n -2. Also have vector B, which is given to me as 4 -6. So we want to harmonize this one also. So we are given 2 vectors. A is n -2, and they're saying B is 4 -6. They're saying these vectors, they are parallel to each other. And they're saying find the value of n. Yeah, this is what we talked about last time. So look at this now. If these 2 vectors are parallel, it means that we can express one in terms of the other. There must be a relationship between the 2 vectors. Yeah, there must be a relationship. So let's see how we can do this. You know, I've said that this A, B, they are parallel vectors. What we talked about last time is that when these vectors are parallel, it means that there must be a particular relationship in that A can be equal to K, B, where this K is a scalar or it's a constant. So we can express one in terms of the other, and there must be a constant here. So what you're supposed to do here, if I have to get the value of n, I have to find that constant. Then if I get the constant, it becomes very easy for me to get the value of n. It becomes so easy for me. Now, let us look at this. So we know that if they are supposed to be parallel, then it means that there must be a particular relationship. It doesn't matter. Don't cram anything. Even if I say B is equal to K, A still is the same thing. There must be a relationship. Yeah, it must be there. So you don't say that it's supposed to be equal. Whatever you use, even if you use another letter instead of K, it is fine. This is mathematics. No need to cram anything. Things will come out on their own if you know the concept, you know how to start the question. So we're having A. So I have to see the relationship. I have to see what is similar. Yeah? Is there anything that I can factorize out? So we look at this one. If you look at A, because my A is given as this, and also I have my B. Look at analyze this. My B is 4, but for B I can factorize out something. You see, for A I cannot, because A is n -2. What can I put out? Nothing, because there is not a negative is similar, not a 2, not what. So there's no common factor there. But again, look at the B. See, when I look at B I can put outside my 2. Yeah, I can put 2 outside. When I put 2 out, it means that I'm going to have here, this will be 2 now. This will become 2. Then down here, I'll be having a negative feeling. Yeah, that's what we'll be have, because we are doing a number, and we're having n -2, then it's -6. So I'm having this. It means that we're having this as n, then this is -2. Now when you come to this one here, we're having 4, then down here we had -6. That's what we had, 4 -6. So even other thing is that you can look at the numbers we have down here. Look at the numbers we have down. It can be like this. Yeah? Also, even if you don't want to use that, look at only these numbers. And I want you to understand every single concept here. Look at 4 and negative 6. No, for 4 and n, we cannot compare anything. But look at, because power vector, that means that they are equal. No, it's not that they are equal. So we cannot equate n to 4. But look at these two. Look at negative 2. Look at negative 6. For power vectors, there's something that you have to multiply. You must multiply a scalar to one of them to get the other. So when I look at this b, you can look at these two numbers down in y. It means that if you multiply this a by 3, I can get this negative. If I multiply this negative 2 by 3, I can get the negative 6. Or still, if I divide this one, negative 6, if I divide negative 6 by 3, I can still get negative 2. I think you are seeing that. So anything that I use, I can divide. When I divide this by this, it means that if I divide negative 6 by 3, it means I get negative 2. Or if I multiply negative 2 times 3, I get negative 6. Yeah? So look at this. It means that according to what we have seen here, even if I use this concept, just use this concept and see. You know how math is so interesting that I don't know. I just know the concept is this, but I don't know what to do, but I know the concept. So use the concept. You know, use the concept. The thing will come out. So we need to find what is this k. After getting the k, then everything becomes easy. Everything becomes easy. Now I've seen that. Actually, I see if you say b equals to a k or k, it becomes very easy. But again, even if you use this, there's no problem. You get the same answer. That's why I'm saying that you don't need to cram anything. Now look at these values in y. So I can say that if I multiply, this is, I can use what I said already here. So I can say if you have negative, if I have this one here, then this is k. I can do this in very many ways because it is good. So we have this. So it means that this a, I'm using this concept. So I can look at these ones down. So it means that when I get negative 6 times k, it will be equal to negative 2. And so when I get 4 times k, because now this k has to multiply everything inside. So it means that still this n will be equal to 4k, because we looked at the equality of these expression vectors. So it means that when I have these two equations, this and this, I can get the value of k. After getting k, then I can put k here, I get the value of n. I can get n. So looking at this, I can say that my k can be equal to negative 2, then divide by negative 6. So I get my k as a third. After getting k as a third, then I put here, I get my n. I'll get my n. Yeah, so these numbers, please never fear such numbers. If you understand the concept, use it. So I also have n, no n equals to 4k. I already have got my k, so my n will be equal to 4 times my k, which is now a third. It means my n will be equal to 4 out of 3. That would be my n. So this is what you're supposed to do. Understand that if there are power vectors, there must be a constant multiplying one of the other. And again, even if somebody uses, let me just show you another way. Even if you just multiply by a, see, it is the same thing. That's why I'm saying that you don't need to cram anything. Understand the concept that we are using. For power vectors, no, this is very true. Even if somebody uses this, I might use this. I say this vector b will be equal to k. So there must be a constant. Now, in this case, I can maybe call this one an s or a c. C is my constant or a scalar. Even if I use this one, see, it will come out. You see, I have my b, it becomes 4, negative 6. So the constant will change, but still the answers will be the same. For n, I say this is n, negative 2. You see? So when I multiply here, it means I'll be having 4, negative 6 will be equal to, this is another alternative that we can use, will be equal to nc, then negative 2c. So I equate those in x, those in y. So when I equate these ones in y, I'll get negative 2c will be equal to negative 6. So when you divide by negative 2 by negative 2 here, so I'll be getting my c as 3. So when I come back here, I want to get n, I'll get, because I have nc equals to 4. You see that? So this will be nc, but my nc, my 3, I already get my c as 3. This will be equal to 4. So when I divide by 3, I'll get still my n as 4 out of. So you still get the same answers. What you need to understand is the concept that for parallel vectors, one of them must be expressed in terms of the other. We must multiply by a scalar. Scalar, a constant, they mean the same thing. That's what I've done, and you end up getting the same answers. What differs is the value of k. Here I was getting k as a third. I get k as my constant as 3, but still n will be the same. That's how we work out that number 6. That's how we do it. That's how we do it. So when you find these numbers, please just enjoy them. Then now we can see, I think the time we have, we can do one more question. There. So there are 10 questions, number 6 now. So let's look at number 7. Yeah, I believe next week we'll be doing something else. And I'm happy even for those who are in senior field. You know, they are thanking, they are giving, they are appreciating, they are giving results for all these vectors, all topics that we have covered actually, even trigonometry. Those people are in senior field and they are okay now with these topics. That means when you go back to school, even if they have not yet been taught, they will be ahead of their fellow students who don't watch a BBSKATI final. So we are having number 7, they're saying that given vectors Sx, we are having Sx is equal to 3 out of 5 into p minus q. Then this is my Sx. Also we have Sp. They're giving us that Sp equals to 4p minus 4q. They are saying that, show that Sx and p are collinear. Hence find the ratio of Sx to Sp. So that's what we have. I think this will be last question. Time is not on our side, but we can do this number. So the remaining 3 numbers, they will. Also, they are different. That's why I want us to do. They are also different from these, but at least the concept we have got can help us. But they are somehow different, and we will do them. So we're having this. We're having Sx equals to 3 out of 5p minus q. Also, I have Sp is given by 4p minus 4q, telling me to show that S, x and p are collinear, or they are lying on a straight line. One thing is that now they have given us the Sx, also we have Sp. Let us do this now. So if we have S, we have x, we have p. They have given us already. Sp is given, Sx is given. So I already have a common point S. Yeah. Now my duty here is to express one in terms of the other, to show that they are parallel vectors. Then that means they are collinear. Then they're saying against find the ratio. The ratio is going to be very, very easy for us. So what we can do here is that we can divide. And before you divide, you have to say there's something similar. You see here, there's p minus q. Also, I can get p minus q here. How? By factorizing out the 4. When I put the 4 outside, I can get p minus q, which is also here. Then I can divide, and the ratio will become very easy. So I can get my, because they're saying hence find the ratio of Sx to Xp. I can also divide like this. I divide Sx out of Sp. Let's do it here. So we'll be having Sx divided by Sp. Then, but I'm not first allowing this Sp to make it 4. So this Sp is the same thing as having 4 into p minus q. So dividing here will be very easy for me. That's why so always there have to be something which is similar. So Sx, this will be now 3 out of 5 into p minus q. Then divide by my Sp, which is now 4 into p minus q. So p minus q and this will cancel out. So I'll be having my Sx out of, so we're going to do all these things in the vector diagrams, but after passing through all these concepts now, vector diagrams will be very easy. That's why I had to do all these concepts here with unknowns now, like p, q, all of them, even the other numbers, you're going to see them. That when you go to the vector diagrams, I want to explain about all these things because you have already seen them. Yes, that's why I'm saying that this question, the way they are arranged is good, and every question here matters because it has a particular concept that you are going to use. So P minus Q cancels out as P minus Q, so I'll be having 3 out of 5. This is divided by 4, like that. So what I do here, I'll get my Sx out of Sp. This will be equal to, I can say this because you have to bring it down, becomes multiplication times 1 out of 4, you get a reciprocal. So it means that my S of x over S of p, this will be equal to 3 out of 20. That's what we have. So where they are having this relationship here means that, and we already have a common point, so they are collinear. They are collinear. So even I can just say that since this S of x equals to, I can multiply by S of t, there's no problem. Even if you find the ratios, because that's one of the questions they want us to do, S of p. So this equals to this. And again, where do you have a common point? So S, x, and p are collinear. S, x, so this means that they are parallel vectors. S, x, and p are collinear. So again, they are saying that find the ratios. So the ratios here, ratio of x to sp. So we just have to divide, take it back the way it has been. So I'll be having, to find the ratio, I'm going to have S of x out of S of p. This equals to 3 out of 20. So the ratio of S of x to S of p will be equal to 3 to 20. So that becomes the ratio there. Yeah, so this is very good, and we are going to use all these concepts in the vector diagrams. That's why I wanted to arrange these questions in that way. In that, in the vector diagrams, they are going to help us. Even those next questions, 8, 9, and 10, I know you can try them out, but still I know that they must give you some challenges because there is some concept that we have to see there. But they are very good questions. So our time is done. I'm going to thank you for tuning in every time we have these lessons, and just keep at BBS Terefina. So the Jakabaka awangale.
Somera Muddiiro lyo ng'ewagiddwa bw'osomeseza omwana wo mu masomero ga Giant Schools omuli kampasi y'Ebombo Kalule n'ey'e Kabalagala toba na bweraliikirivu bwonna olw'omusingi okutambuzibwa ebyenjigiriza n'ensoma y'abayizi ey'omulembe. Mu masomero gaffe gano gonna tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuuka ku siniya ey'omukaaga, nga tusomesa abaana okuviira ddala ku mutendero gwa kindergarten okutuuka ku kibiina eky'omusanvu. Tulina abasomesa abakugu mu kubangula abaana n'okubateekateeka. Ebibiina abaana mwe basomera eby'omulembe omuli buli kimu ekikwata ku ebyo bye basoma, ebisuula ebyazimbibwa obulungi, ebigazi ate nga biyonjo. Okumanya ebisingawo tukubire ku nnamba z'essimu ez'owammanga.
Baby Junior Jelly owulira omukwano gwa maama n'okufaayo kwa maama. Baby Junior Jelly owulira engalo za maama ansingira bulijjo anyiriza buli kadde. Baby Junior Jelly abatogo beetaaga.
Nze nga jjajja bazzukulu bange okusanyuka n'okufuna emirembe. Ekyama kyange mbasiiga ebizigo bya Baby Junior Jelly biwummuza bigonza olususu lw'aba baby, birimu akawowo akalungi, bigoba okubutuka okuleetebwa diapers birungi ne ku nsusu ez'entondo.
Baby nduya.
Oh yeah, officially is my friend. I don't need to worry for the rest of my day. Kuna Matata, voice and data bundles. Free OTT. Now I can social distance, call you all day. Kuna Matata.
Hakuna Matata, the newest bundle from Ageesigika. Lots of data, unlimited calls, and free OTT. Dial *133#. Select your preferred daily, weekly, or monthly bundle, and Hakuna Matata. Stay connected, stay safe. Ageesigika is regulated by Ghana Communications Commission.
Hakuna Matata.
Orange sky view.
Everything brand new with orange sky view.
Orange sky view. The sky is the limit.
Everything brand new with orange
Sky view will cool you down under the hot sun.
Everything brand new with orange sky
And when you're feeling blue, refresh yourself. Quench your thirst if you're craving for the best. Sky view is your taste.
Refresh yourself with a cool, fantabulous Sky View. Sky View, go extreme. Sky View Orange is a product of the Reham family.
Omuzadde ng'oteekateeka okunoonyeza omwana w'essomero ery'okumubangula mu bintu eby'enjawulo omuli ebyenjigiriza eby'omulembe n'okufuna amagezi ku bintu eby'emikono. Essomero liri limu lyokka, Janan Nursery and Primary School, erisangibwa e Bombo Kalule. Ffe tulina omusingi gw'ebyenjigiriza ebisookerwako nga tusomesa abaana okuviira ddala ku mutendero gwa kindergarten okutuuka ku kibiina eky'omusanvu. Tulina abasomesa abakugu mu kubangula abaana n'okubateekateeka. Ebibiina abaana mwe basomera eby'omulembe omuli buli kimu ekikwata ku ebyo bye basoma, ebisuula ebyazimbibwa obulungi, ebigazi ate nga biyonjo, kompawundi yaffe nga zibulungi nga endabika yayo eyamba omwana okulowooza ku ebyo by'asoma. Abayizi baffe bafuna akadde ak'okusinza mu madiini gaabwe ag'enjawulo. Wano ku Janan ebyokwerinda tuyitwala nga kikulu, anti tulina security camera ezisangibwa mu buli kasonda k'essomero. Abayizi baffe baweebwa omukisa okwetaba mu by'emizannyo eby'enjawulo omuli okuwuga, okusamba omupiira, basketball n'okuzannya netball. Tufaayo ku by'obulamu nga tulina eddwaliro erikola okumala essaawa 24. Endiisa y'abaana ezimba emibiri gyabwe n'okubakuma nga balamu. Kati nno gwe omuzadde ekirabo ky'oyinza okukwasa omwana wo mu lusoma lw'omwaka 2020 muleete ku Janan Nursery and Primary erisangibwa Bombo Kalule nga n'okwewandisa kugenda maaso kati eri abaana b'ekibiina ekisooka. Okumanya ebisingawo tukubire ku nnamba z'essimu ezowammanga.
Okwewala oba okwekuuma akawuka ka COVID-19 akalumya ensi yonna. Bino wammanga by'olina okukola okuziyiza okusaasaana kw'akawuka kano aka COVID-19. Naaba engalo ng'okozesa amazzi ne sabbuuni buli kadde. Weewala okubeera mu bantu abangi buli w'obeera. Weewala okukwata mu maaso, ku nnyindo, ku mumwa n'engalo nga si nnyonjo. Kolola oba nyiza mu nsonda y'akakokolako oba okozesa akatambaala bw'omaliriza okasuule mu dustibin yo. Bw'ofuna obubonero obulaga COVID-19 sigala ewaka okubire aba Ministry of Health ku 0800 oba ku 0800 okufuna obuyambi. Wabula bw'oba oyagala kuzza bujja intaneti yo eya Rock Telecom, kozesa emikutu gyaffe egya digito nga Mastercard, Visa ne ba agent. Osobola okunyiga *252#, sigala ewaka, sigala nga weekuumye, sigala ku Rock Internet.
Rock Telecom. Okwerinda ekirwadde kya coronavirus ekiyitibwa COVID-19. Tufaayo nnyo ku bulamu bw'oggwe omulabi wa BBS Telefina naddala mu kiseera kino eky'akawuka ka coronavirus. Bw'oba olina bino wammanga: omusujja, ssenyiga n'ekifuba, okwasimula ennyo, omumiro gukusiyirira, obuzibu mu kussa, oba obunafu mu mubiri, osaanye okuba omwegendereza. Buno bubonero obw'ekirwadde kino ekya coronavirus ekisaasaanira ku misinde egya waggulu. Osaanidde okwewala bino wammanga: okukwata mu ngalo n'okugwa abantu mu bifuba. Tosemberera muntu alina bubonero buno obukutegeezeddwa waggulu. Bw'oba olina ssenyiga, weewala okutambulira naddala mu bifo ebirimu abantu abangi. Eddagala ly'omira lirina okuba nga likuweereddwa omusawo omukugu. Ebiseera ebisinga genderera nnyo obutawanda mu bantu. Ate bw'oba n'olugendo olufuluma eggwanga, weewala amawanga agakoseddwa ekirwadde kino. So nga ate era gwe atalina bubonero bwo waggulu, kola bino okwetangira: naaba mu ngalo ne sabbuuni oba eddagala eritta obuwuka eriyitibwa sanitizer buli kadde. Bikka omumwa gwo n'ennyindo bw'oba oyasimula oba ng'onyiza eminyira. Weewala okusemberera omuntu akolola oba anyiza. Tusaanye okuba abeegendereza kubanga engalo zaffe zikwata mu bifo bingi. Kyamakulu nnyo weewala okukwata mu maaso go. Bw'oba olina obuzibu mu kussa, ekifuba oba ssenyiga, ddukirawo mangu mu ddwaliro erikuli okumpi. So nga ate era bw'oba olina omulwadde ow'obubonero bwa coronavirus gw'ojjanjaba, yambala mask, gloves wamu ne overall. Fuuyira n'eddagala ebifo ebitera okukwatibwako ennyo ng'enzigi, amadirisa, eminyolo gy'enzigi, egy'emmotoka ssaako n'ebifo ebirala. N'olw'ensonga eyo tusaanye okuba abeegendereza nga tugoberera ebyo ebitugambiddwa waggulu. Ssaabasajja Kabaka awangaale. Ekkanisa ya Seventh Day okuyita mu Central Uganda Conference CUC eteeseteese camp meeting mu ddiro lyo embaga y'ensiisira wano ku BBS Telefina okutandika ku Ssabbiiti eno ng'ennaku z'omwezi 12 okutuukira ddala ng'ennaku z'omwezi 19 omwezi ogw'omwenda. Eno yakulagibwa buli lunaku ssaawa 2 okutuukira ddala ku ssaawa 3 ez'ekiro era nga yakutambulira wansi w'omulamu ogugamba nti okufuna amaanyi agamazaako embiro. Tusuwe omulabirizi eyawummula Dr. John Kakembo ng'atuyigiriza ssaako n'okutusomesa olwo kwaya ez'enjawulo zituyise mu kutendereza n'ennyimbe ze zigulumiza omutonzi era ng'ekyawandiikibwa mu mbaga y'ensiisira eya 2020